This is a story about things that have never happened. It explains how I met Reed, and it will also serve as my introduction. This is a four-story structure clad with brick and aluminum glazed framing, and there was considerable water damage on the walls and the ceiling. So the original architect hired me to investigate the cause of water intrusion. He said the reason this building leaks is the incorrect maintenance because the curtain wall weep holes were sealed over. And I said I can see that several weep holes were sealed over here and there, but the leaks are at the opposite side of the building. Also, would it change if they are not sealed? As you can see on this picture, these weep holes which are not sealed are not working anyways. When weep holes work, you would be able to see streaks below them. So they said it's also deferred maintenance because sealant and roofing has deteriorated. To which I said, well, would it matter if they were brand new? They were never installed correctly. The worst was the zigzag configuration of the roof flashing at the base of the brick veneer, which deposited water inside the roofing. Here is the thermal picture superimposed over the roofing, showing wet areas just in this small area. Also, perimeter sealant joints were installed at the incorrect locations according to the original architectural drawings, so they would leak regardless, deteriorated or not. At the end of the day, my report contained over 20 items that did not exactly corroborate the version suggested by the architect, who didn't like my report, so I had to agree to substitute broad generalizations. The resulting report was sent to the architect's lawyer for review, who returned it several weeks later with comments. I had to edit it again in order to get paid, and at the end of the day, the report was void of any essence. But the architect still didn't feel quite comfortable with it, so they issued a parallel report in which, guess what, they blamed the incorrect maintenance and gradual deterioration. Anyway, this project presented a perfect opportunity to upgrade the building for energy savings and hurricane resistance. First, windows were dismantled, allowing for glass substitution with laminated impact-resistant glass, and there was some interior renovation going on, so the interior walls were ripped open, and there was a space behind studs allowing for a thin sheet of continuous insulation, which would cut the energy expenditures a good deal. Adding thermal insulation to a non-insulated building is a low-hanging fruit in terms of the payback. It costs pennies on a square foot if you renovate your building and have access to these assemblies anyway, and gives you a simple payback of a few years. Reed will talk about the similar payback of most frequently considered mechanical retrofits. Another item on the list is glazing, which racks up cooling bills. I'm always last to exit, so I shot this video a couple of weeks ago. Have you ever wondered why window shades are down when airplane is parked at the gate? Just eyeing this building, I would say the window to wall ratio is in the range of 60 to 70%. Now the reason why we are using the windows is to let light inside. This is why we concede to pay extra every year for the heat they transfer. The funny part is there are only 1 in 9 glass panes in this building that are vision lights. The ones marked pink on this picture are only used for architectural decoration. So this building was easy to upgrade. And we are not talking here about bricking up the remaining windows. Only 1 in 9 glass panes were needed to make these windows impact resistant. We're dismantling these windows, and at the same time, Florida State was giving grants to upgrade hurricane resistance, so the replacement would eventually cost less. We also could have added insulation to the exposed areas at the cost of the material and labor alone. How much electricity bill could have been shaved? Would it make sense at all? Good question, isn't it? Well, this is why years ago the Florida State made it mandatory for each public building to be assessed by energy rating prior to any renovation or acquisition. I don't believe this happened on this job. Now, let's for a moment imagine that these walls were actually thermally upgraded by adding thermal insulation. Would this building look bad as a result, all moldy and smelly? This is a spontaneous growth of mold and mildew in presence of humid air. So the answer is yes. If you cut the energy intake, the building would require less air conditioning. Makes sense. This is why we would insulate it in the first place, right? Here is a video from one of the laboratories located in a recently renovated healthcare facility, which I was asked to investigate on another project. There is lots of mold and mildew on the ceiling, particularly on the air conditioning diffusers. They are 2 years old and they are already rusted, along with refrigerators, file cabinets, and other rusty stuff, including this expensive laboratory equipment. This is how one of the air handlers in this building looked like. In order to deal with interior contaminants, the hot and humid air exterior makeup air is sucked inside, causing excessive humidity levels and spontaneous microbiological growth inside this building, because there is no dehumidification. So here is a related question. Let's assume that you added some extra thermal insulation to the walls of your building in South Florida. How to avoid your building looking like that? We had a relevant question at our survey of architects called Elementary Scientific Literacy for Architects, and only 64% responded correctly. The interesting part is this particular building houses laboratories and is located in hot and humid climate. Called so because it's hot and humid outside. If this air gets inside, it would condense because the interior is cooled below its dew point. This is why we normally design the forced air system in the buildings in the south to be positively pressurized to keep this air out. Not so much in a laboratory building, which is normally negatively pressurized in order to restrict interior air contaminants. In this one, I was later told that mechanical pressure was so strong it was popping doors open. This kind of building is most challenging to engineer properly, so it seldom is. This was a primer on overlooked secondary consequences of energy improvements, if they ever happened. Anyway, this particular job turned out into a typical joint caulking project, which, by the way, you don't really need an architect for. You need a building enclosure scientist to tell you, for example, that silicone sealant won't cure under certain circumstances, or whether the substrate material is compatible with the structural sealant. Anyway, the architect did not consult us about the remedial design, but we were hired to perform the water spray test after the 2 windows were sealed. We followed a procedure called the Quality Assurance and Diagnostic Water Leakage Field Check of installed storefront, curtain walls, and slope glazing systems. So the window held fine, but the brick veneer piers next to a window leaked like a sieve, producing 8 leaks because the seal was constructed at the wrong location. So we had no leaks from the window, but 8 leaks from the adjacent brick veneer and the transition. What was the result of the test? It passed, because this test scope is limited only to test the fixed glazing. Why? Because in the new construction scenario, the scope limitations keep subcontractors from fighting with each other. There are few tests which could be applicable to existing buildings as opposed to new buildings. Well, then we recommended miscellaneous alternative remediation methods, and we were surprised to hear that architect asked the contractor to purchase and install apply silane siloxane sealer, which we recommended against. Why did the architect do it? There are several reasons. First, because the sales rep easily convinced him. However, the contractor performed their own water test after the sealant was applied, and water went straight through. Who knew? At this stage, the building was left leaky. It was one of the top 10 architectural firms in the United States. I never heard back from them, which is probably good news because I sleep better. I lost my first big client. But sometime later I got a call from Reed and gained him as a friend and a client. Reed happens to be the director of maintenance of a number of buildings, including the next one I'm going to show to you. When I asked the architect why he specified a surface-applied sealant siloxane sealer not suitable for this application, he said that according to the literature presented to him, it passed the laboratory test. Yes, I said, well, it was ASTM E514, which is well known for its weakness. After 180 days, there is a 50% performance reduction rate. Coincidentally, I recently was asked to test 4 different sealers of this type in my laboratory, and after 1 month of testing, according to the test results, 3 of the 4 sealers worsened the stone's ability to resist salt attack by as much as 200%. So conclusion was, if you don't spend your money and labor on sealing your stone with those sealants, your facade will last 3 times longer. I sent the results back, and several months later I got an email saying that they want to use the sealant which I identified as the worst, which part they didn't understand. Have you ever asked yourself what happens when your contractor, architect or engineer have a question about the building science? How do I stop this leak? Will the sealant be compatible? How much insulation should I place in the wall? Which way the facing should face? What type of glass would make my building code compliant? So according to the survey I told you about earlier, you better flip a coin than ask an architect a question about building science. So have you ever wondered whom your technical advisor, quote unquote, whom we earlier knew as a product rep, calls with those questions? Well, have you ever tried to get this number from a sales rep? Good luck. They guard it with their life. They call a building scientist sitting somewhere in a lab if the company has one. There are approximately 300 of those building enclosure scientists in America who come each year to one secluded spot in Massachusetts forest to celebrate some strange rituals. And recently, under auspices of National Institute of Building Science, we were given a more official venue. So every 3 years, we organize a conference called BEST, which stands for Building Enclosure Science and Technology. As it happens, one took place 3 weeks ago. So knowing that I will talk to you soon at this conference, sitting in the evening in an Irish pub, I asked my colleagues what assemblies help them pay off their loans quickest or made them simply outrageously rich. Here's the list we came with. This is not a formal list, but you may still want to post it on your wall. Would you stand below this building? Or would you stand below the ceiling? Would you park your car here? Or you would walk inside this building? Of course not. Sounds like a common sense to avoid the known risk. However, I can see examples of these every single day on the new and repair projects. There are only 300 of us, making 1 per every million people in the United States, or 1 per every 300 registered architects. So the message doesn't quite come through. The second reason why the architect rejected our recommendation was the only surface sealer, which would work at this time, would produce a uniform color, slightly changing the brick appearance, as illustrated on these pictures. Have you noticed the difference? This is one of the buildings Reed asked me to investigate soon after. It was redesigned from a shopping mall and casino into a marine laboratory building in the year 1998. Water was dripping from exterior soffits, so I had to cut a big hole in the stucco ceiling and flat the terrace above, only to discover a big hole in storm drainage elbow, which means that the building was never properly commissioned, meaning that there was no storm drainage pressure testing required by Florida plumbing code. It was redesigned from a shopping mall and a casino into a marine laboratory building 6 years after Hurricane Andrew and 4 years after the South Florida Building Code in this county implemented lessons learned, including things like protection of openings, etc. The building is located on the Atlantic beach in front of the Intracoastal Channel, and this facade is facing the Atlantic Ocean, only a couple hundred yards from the shoreline. The finished floor level is below the base flat elevation, and a relatively light wind will be enough to flood the ground level. Here you can see the storm surge levels tied to the wind speeds. Well, it may be a pretty building, but none of the exterior windows and doors in this building are rated for wind and impact. Another issue is the concrete walls leak. They are all cracked at random locations. Here you can see my diagnostic water spray testing equipment. Please note the sophisticated technique. Uh, This is kind of obvious. The reason wall cracks in the movement joints are located at wrong locations, according to the architectural drawings. They are placed where no movement can be reasonably expected, at the bottom of walls instead of the slab deflection joints, and at the center lines of concrete columns, as opposed to their sides. To the contrary, they should be placed at these locations. This was the case in another leaky building as well. This entire wall has high maintenance control joints which do not perform any function at all because they are all at the wrong location. Here is another building. Taking pictures of this building is prohibited, so I had to download it from the internet. This building stores personal information of almost everybody in this room, including myself. It is clad with concrete precast, therefore most joints are at the correct locations. The trouble is that they are incorrectly sized. Each piece of precast is so large that it moves 16 times more than the size of this joint, squeezing the sealant out, which means that resealing it is totally futile. You need to either widen it with a diamond saw or use a strip of a face-applied membrane. Buildings have their bottlenecks, which, if properly addressed, can serve as long as we want them to. The greenest thing you can do to your car is to keep driving it as opposed to replacing it, and building components are no different. Take roofs, for example. On your average aging roof, architects and contractors would be pushing for replacement, while coating reps would be pushing for recoating. None of them would be correct unless they tested your existing roof, which they didn't. The Florida Building Code is very specific about the moisture content threshold applicable for repair versus replacement scenario. The area ratio here is in the range of 10%. So instead of procession of dump trucks carrying your old roofing and insulation to a dump yard, you can in most cases safely redo your existing roof and improve its hurricane resistance. You would be surprised how often I am asked to test whether the inferior specs were met. For example, I verified the solar heat gain coefficient of glass on the newly erected office tower in Miami, which occupants complain about getting tan at their desk and unbearable heat from windows. As a result of my test, I found that the glass was precisely what architect specified. The trouble was that they specified glass which let in more heat than light. We normally want to design them the other way around. Who knew? The owner said, "Oh, easy, we are going to place a solar tint film on windows. This is what your average salesperson recommend. But trust me, it's not a good idea because your glass will crack from the excessive thermal stress, which is why the glass manufacturer would void its warranty if you do so." I suggested they cover the tower with an advertising media, which would limit the sun access and collect money for the new glass. The funny thing is the correct glass would not cost a penny more if it was specified correctly in the very beginning. Another issue is wrong tests prescribed. They call me and ask me to submit a proposal for such and such a test. I ask, why? Because this is what the architect said. Aha. Yet another issue is the test result misrepresentation we talk about. Here's another building Reed asked me to investigate. It was standing there for 5 years vacant because of mold and mildew. They suspected window leaks were the reason for the observed mold and mildew, and therefore Reed sent me there to investigate those leaky windows. They made me wear hazmat gear before I could get there. Needless to say, windows were in perfect shape because they were not used very much. Instead, they had a pure case of vapor barrier on the wrong side, ceramic tiles and vinyl wallpaper on the interior, while the exterior of the building was not only vapor permeable but also constructed without seal flashings. Well, another thing was Reed ran air conditioning around the clock to dry the building. At this time, Reed spent approximately as much on the annual maintenance as it would cost to demolish this building, so he sent me there with an agenda. He said, "Give me a reason to demolish this building." I said, "With all due respect, I believe this building is perfectly salvageable. First, switch off the dumb air conditioning because you are feeding mold at your own expense. Get rid of the vinyl wallpaper and tile and add flashing on water tables. The hot and humid climate is called so because it's hot and humid outside, while we want to keep the interiors at comfortable temperature between 70 and 75 degrees. The reason why this air from boiling kettle wants to get inside is because it's cooler inside. Stop the air conditioning and it has no more reason to get inside and condense. You can add perimeter heating at problem areas in a vacant building, which would dehumidify the air without creating potential for condensation and moisture damage. But first of all, you need to remove the offending vinyl wallpaper and ceramic tile. Next, you may want to coat the building exterior with something impermeable to water vapor, which incidentally is the opposite way you would do in a mixed and cold climate, which is the frequent reason why your salesperson typically has it wrong. So here's the summary of points to remember.